Hello, folks. Welcome to today's stream, which once again was kind of unplanned for. So we've been doing quite a lot of streaming this week, and that streaming has been mostly level design, asset design, that sort of thing. Today's stream is going to be a little different. I want to do a little bit of memory optimization. Right? We have this memory stats view here in the game. I'm hoping this comes through. This is an IMGUI window, so it's a little tricky to resize. But a few things here that kind of annoy me a little bit. Specifically this graphics API and generic memory allocation that's going on here. So you can see the allocators that are yellow. They are actively being used. If I remember correctly, an allocator that's yellow has been allocated with or freed within the last second or so. I mean, I guess technically all the allocators that have more than 0 allocations are actively being used. But what I mean is we are actively allocating and deallocating at runtime. And so some of those are kind of expected, some of them not really. And I think we can get rid of some of them kind of easily. You can see here if I just stop for a bit and sit here without doing anything, I can even rotate the camera to look at different things. There's really no not a whole lot going on. Physics is doing its thing, and the network layer is doing its thing, and then we have the STL, which has, like, count-wise has the most allocations in the whole system. Almost 30,000, but the size is not very big. And STL is STL. It's like covering most of the lists and containers and all of that. It's kind of tricky to get rid of unless you change the way you program things. Let me just lower the music volume a little bit. So yeah, I think I'll probably have to kind of live with the STL allocations being what they are. Maybe I can try to get rid of some of that. Count actually kind of goes up a little bit, but then it goes down again, so I don't know. Yeah. That's probably like something to look at separately. But the stuff that annoys me is the GFX API allocation can't just sort of varying that much. And also the generic allocations just going up and down. And I think we have basically the node graphs to thank for that. Because if I'm standing still here, there's really kind of not a whole lot going on. There's an engine sound, which is technically driven by a node graph. But it doesn't really do much when we're just sitting here. I think the particle systems are probably to blame for most of that stuff. So we have this weird, kind of in progress, to be honest, and kind of ugly, to be honest, cartoony smoke thingy, or dust actually. And then we have some like some of this, like, what do I even call that? There's this other sort of billboard particle thing, which we can see here if we pause the game, like these kinds of things. They're both driven by node graphs. So, like if we look at the particle editor, so this is the cartoon smoke thingy. There's a node graph that looks like this. And I think this is basically the culprit here for just allocating lots of things on the renderer. And then the other thing, which is probably here as well, is this gravel things. So longitudinal slip. This uses the billboard renderer. The other one uses the mesh renderer. Because like these spheres here are actually sort of meshes. These guys, they're 3D, even though they're just spheres. So it's kind of tricky to see. And yeah, I have a feeling that the memory use of those is a little suboptimal, and that's why we get like this pretty large jumps actually in the GFX API section there. You could see jumps like 15,000 allocations. Still only 6.12 megabytes, so it's not that large sort of size-wise. But we don't have that many particle effects running. And we might have quite a few later down the line when we have other cars that are more sort of final, closer to final. So I'm gonna want to do something about that. Pretty sure. And also I'd like to separate out the node graph allocations from the rest of the allocations, because you can't really easily see now what's what. You just have this generic the generic category there has like 13,000 or so, almost a gigabyte allocated. That's kind of to be expected, because the generic stuff is just like, if you don't specify, I just said that very strangely, if you don't specify which allocator you want, it goes into the generic allocator, and that's very handy. But I think we might want to have a category for the node graphs. So let's do a little bit of programming, and specifically we're going to do a little bit of C++ programming, because this is sort of like engine side stuff. So we're not going to do Zig, at least not right now. And yeah, I had a little bit of a look at this earlier. So here we have, for example, this is an SDF particle node, but we can look at the mesh particle node. Mesh particle renderer node. So it's like if we have this guy, and we create an instance of this guy. Well, it basically goes and creates an instance of this node here, this mesh particle renderer node. And you can see it has some things. It has a mesh resource path, this is a material resource path, and it has a Boolean value. So those are the things that it needs to create one of those instances. And here we actually have the state, so the thing that is created on the heap when this node is created is this node state struct has this renderer here just inline sort of in the state, which is good in a sense. But on the other hand, if this node gets created and destroyed all over the place, then we just create and destroy this renderer too all over the place. If that makes sense. And we might not want to do that. We might not want to create a renderer and then use it for like a second. So basically 60 updates and then throw it away. Because this renderer does quite a lot of things. It acquires a mesh resource and a material resource. And then it probably, it gets the shared mesh and the shared material out of them. But anyway, this causes all kinds of allocations to be done. And if we have like one of these, if you have one of these dust effects after the car, right? It gets like started and stopped all the time. So we're just like creating and destroying this renderer over and over for no real reason, essentially, because this mesh resource path and material resource path, they're just the same every time. They're just hard-coded here into this. So we have unit sphere, very interesting mesh, and cartoon smoke continuous no shadows bin material. What would actually happen if we just put like a cog here, right? I guess so. So let's build this thing. Right, so now if we run this, we should get the cogs there. We can just jump to that car over there. And see, yay, now we have cogs coming off the thing. Beautiful. Beautiful stuff. But yeah, the idea here is that if this car now sort of lifts off the ground, it is probably running until the end, essentially. And then we get like, then we let the instance be released. So it just releases all its resources, right? But then we almost immediately after that we just fall down again and touch the ground, and we create a new one. And it creates a new renderer that has the exact same mesh, the exact same material. It's kind of wasteful. We could just reuse those. And technically those would be then separate instances of that effect, but they're coming off the same material description, right? Because there's sort of like the same node graph. So here we have one renderer doing this, and it's gonna die very soon, and here we have another one that's just gonna stay alive for a bit longer because we just touched the ground again. So they could just use the same one, right? We don't need to create one per instance. That's what I'm thinking. And out of this node graph, we get like get an effect description. That is technically what gets created when you load one of these effects. And then out of the description, you can create instances. So maybe we don't have the instances create their own renderers just to throw them away when the instance dies. Maybe instead we have the instances request one of those renderers from the description, right? That makes sense. I think. And to be able to create those renderers, we basically need this. We need this information here in the node. So go back to the node. The node gets that stuff from this node property stream here. So these are the three properties that the node has. We can read them out of this, and then we can start to use them. And if we don't want to make like big changes to how the data is actually stored here, we kind of just like create those renderers then on demand, right? So this guy has this Merlin Sprinter user data. Effect description. So this is the guy that would provide those things. Yeah. Yeah, I think this is gonna work pretty well actually. Let's see if we can make that happen. So basically what I want to do here is there are three kinds of renderers currently. There's the billboard particle renderer, there's the mesh particle renderer, and there's the SDF particle renderer. And I think the billboard renderer and the mesh renderer are basically similar. They each take a render scene, but that's kind of, I don't know why they really need to take that. The instance could, or the description could figure out which render scene we're in. Actually, yeah, this probably needs the scene, but the instance can figure that out. We don't need to tell the thing which scene it needs to go in. Because the rendering of this stuff is actually just done through the scene here. We just add immediate mesh batch. And this is like all of the particle meshes just go in here. Yeah. And like one something to render in the scene is just like one of these render instance data things. Where sort of arguably the most important thing is just the world matrix. Right, so we have three different renderers. So we should be able to basically just create some methods here to sort of get one of those renders based on the data. And maybe we can even do like just a plain old linear search or something here to find the correct renderer. I think that might actually be, would that be like the easiest thing, or do we need to hash the data somehow? I don't know. We'll figure that out. So we'll do Merlin SDF renderer. No. Particle. No. Oh, it's actually probably just SDF particle renderer. Yeah, it's Merlin is the namespace. Class billboard particle renderer, and finally mesh particle renderer. So those are the three kinds of things we want to ask this description for. If that makes sense. I'm gonna move this off to the side so we can look at these actual renderers here. It's particle 1, and we have the as a node. We don't want the node yet. Close to the right or close to the left. Doesn't seem to be such a thing in this version of Visual Studio. Jesus, I have many of these guys open here. How many files do I have? Like a couple hundred. Alright, there we go. And billboard renderer CPP. So we have SDF particle renderer H, billboard particle renderer H, and mesh particle renderer H as well. So we can try with start with just one of these guys. Let's start with the mesh one, because the mesh particles are the most sort of visible there, so we can just clearly see if there's anything visually wrong with them when we get them like this. So let's do mesh particle renderer, and we're gonna return a pointer to this now. So we'll do like mesh, get mesh renderer, right? And the sort of information we want to give it here is basically like these three guys. Let's see if I can remember how to program C++ after doing Zig for very long. So we tell it, hey, I want a mesh renderer with this mesh resource path, with this material resource path, and whether or not it should sort its particles. Those are kind of like the criteria. What is this sorting? Batch sort instances. It just goes there probably. Yeah, it doesn't do anything else with it, but it's an important thing to keep in mind, because we might have, at least in theory, might have two mesh renderers with the same mesh resource path and material resource path, but they differ in the sense that one sorts the particles and one doesn't. So let's put this here. And I probably need to include some stuff here for this to work. Mesh particle renderer. Let's actually group these together. Billboard SDF. All right. And then I'm thinking that this guy probably might know something about... Does this thing seriously not know about the client? That's surprising. Okay, well, it knows the manager, I bet. Yes, the manager passed to it here when we initialize this init. So when we load one of these files, you get this node graph handed to the system. Actually comes in through this file here, and then we do the load effect data, and this initializes a node graph description. This is sort of like the loaded all of this data, and then all of this out of that you can create instances of this node graph. But to be able to load that, we need the manager, and the manager is passed to us here, and I think the manager knows the client, right? The manager is initialized with the client. Yeah, it's a friend class of the effect description. It also has a get client. Right. So we can do core basis client. Come on, client. And then we also need the renderer. Because out of the renderer we can then get the primary scene. Yeah. I guess we can justify just having that there as well. And the renderer, we can actually get a pointer to the renderer. Maybe we'll do that, and then we'll hold on to that. So we'll just do forward declare class renderer. I'm gonna just hold on to it here. So renderer. This is actually basis renderer, like so. And then here in init we can just do renderer is renderer get ptr, because that never changes. That's just a kind of like a singleton. In fact, I think it is a singleton. Right. So basically here is where we want to sort of figure out, hey, do we have one of these guys yet? Or do we not? Right? And if we don't, then we want to create one of those. I was thinking that the instances would need to somehow return the renderer when it's done, but maybe not. Maybe we actually don't need to do that. We can just get rid of them when we actually de-initialize this whole description. So it's somewhere here, like probably like the destructor there. I'm thinking. Yeah, I think that makes sense. So, as just a way to test out what we have here, we could do how should I actually do this? Maybe I'll do like struct cached renderer. And then the cached renderer has a pointer to a particle renderer or something. And there's this base class here that the thing's actually used to like drive this thing. Update the particle renderer. Then render using it. Is that actually going to cause us issues? Yeah, it is, isn't it? Because this render is kind of, they're kind of stateful. They're annoyingly so. They are stateful. And so essentially each node expects to have its own renderer that no one else is going to poke at. Right? And that means that we actually we will have to sort of release those. We need to get one, and then when we're done with it, we need to release it. It's still better than what we have now, because we can keep that renderer around and just reuse it for later instances. But it doesn't mean, it means that all instances can't actually use the same renderer. That's what it means. Okay. Yeah, so what happens essentially every frame that we render is that we call update. We pass it in a particle store, which is like a place where we have allocated particles. And then we actually add those particles to a batch. Before that, we clear the batch. And then later in the frame we call render, and we actually add those things there. Okay. And the SDF renderer actually has a material. Yeah, look at this. Okay. So this guy actually has a material that this is even more stateful than the other ones. Okay. Yeah, I still think this is going to be better than what we have currently. And it's going to work with all of these three ones. But basically, that what this means is just that we have sort of a renderer cache that we get stuff out of, and if we essentially give it some criteria. Hey, I want these kinds of renderers. If there is no such thing, it creates one, returns it, and then when a node is done with it, it just returns it to the cache, so that another node can then get it from there. And there's a pretty high likelihood that an effect description, like one of these guys, not an instance of one of these guys, but the actual type of effect. There's pretty high likelihood that several instances will be played back and will be requesting the same kind of renderer from there. That makes sense. Yeah. Alright, let's get to work. I think I know enough now, but it's going to make this stuff here in the description a little trickier. Just because basically whenever we add a new renderer type, not that I know if we're going to do that, we need to change this a little bit. Right, well, several of these guys actually have mesh resource paths and material resource paths. That's actually a shader resource path. Okay. So what we could do is we could create here inside this struct, we could do like basis string mesh resource path string material resource path shader resource path SDF mesh placement scheme. Yeah, what is this? What is this? It's just that. One mesh per particle. Okay. Yeah, these renders are they're just like different enough that it's annoying to create like a unified struct like this. So what I could do is just like hash all of this data. And that would give me a hash, which is just a number. And then I can stick it like in a hash table or just do like linear search. Trying to find another one. Linear search is perhaps just the best and easiest and fastest here, because we won't have that many renderers per instance anyway. A little bit of coffee, have a think. Maybe what I'll do for now is just quite simply do the interface here, because we can look at the implementation in a little bit. So when you want a mesh renderer, you basically have to give it this, and you get back a mesh renderer. Then when you release the mesh renderer, mesh reindeer, yeah. Then you have another function which you call. You can either you can either have just a single release method for all renderer types, so you can have it per type like this. Actually, you know what? I don't want to pollute this class with all of this stuff, because this might get annoyingly complex. So let's actually just create a new thing for this, and we call this Merlin particle renderer store. Oh, cache probably. Yes. Thank you very much. And we create the CPP file as well. And then we go in here, polygon renderer cache, and same thing here, except we don't have a sorry, there we go. Particle. So that would be source, and that would be CPP. Oh, except that's node's source. We don't want it there. We want it there instead. Yeah. Something like that. And then we'll just add one of those guys to the instance. Sure. Oh, not the instance, but the description is what I mean. So let's add here, include Merlin particle renderer cache. And we'll get rid of that. And here we just do, well, let's put something in the file to help it out a little bit, right? Merlin class particle renderer cache. Probably has some public parts, probably has some private parts. Yeah. And it probably has these guys forward declared here. And actually, maybe it actually has some basis stuff as well, because I think this is perhaps now the place that should actually cache the renderer, right? So do like basis renderer. Renderer. Thank you very much. Renderer. And it'll probably need the client as well. Those will have to be, or the client will have to be passed from the description. So we can do init. I'll just pass it the basis render, no, basis client. And then we'll want to have a d in it so that we can actually release those renderers, which in turn releases all the renderer resources in like a controlled fashion. And then this thing, or these kinds of things, they just move there, right? Now we can add one of these guys here, so we'll have like a particle renderer cache. Renderer cache. Yeah, that's fine. And I'm gonna do like a basis force inline render cache. Like that, so you can actually access it from the nodes. It's called particle render cache. Right. Right, we need to forward declare the client here as well. Like so. And then this guy probably doesn't need the renderer at all. Let's get rid of that after all. And it doesn't need that either. Yeah. So this should be fine. We can just get rid of that. Well, basically what we want to do here instead is here in the init, I just want to do renderer cache init and pass it in, pass the client, which we can get through the manager. Get client. And here we can release all the instances, and then we can do renderer cache d init. Yeah. That should be good. Merlin Manager allows you to get one of those instances. Load effect. Oh, sorry, not instances, but descriptions. You give it the resource path to the actual file. It returns a description. And yeah, it acquires it if it can't find it. Otherwise, it gives you back the thing that it has already done, created for you. And then at shutdown, it just goes and deletes them. Yeah. So this is now where it would delete those renderers as well. That's good. Yep. Yep. That will be all right. Right, allocated particles. This is an allocator handle. So this is, basically determines in which allocator is used, which in turn shows up in that stat window, which allows you to figure out which part of the game is actually hogging memory and or allocating and freeing memory. More than you'd like. But okay. I think I'll keep it around. At least for the time being. Right, then we have mClient and mRenderer. So let's just initialize those dudes. Here we do mClient equals client. Okay, what? And we do mRenderer is renderer get ptr, and we actually need to include like both of those. Core client and renderer like that. Right, so the most simple implementation of this, which is not going to actually make us any less fragmented on the memory front, is just actually to allocate a new one of these guys. So let's make sure that works before we do anything else. I'm gonna have to include those renderers here. Am I not? I actually don't need those. Let's have a look here. Did I have it here previously? No, I don't have any of those there, so let's just remove them. And I don't think I even had the client, because I'm not really using the client, I'm just passing it along. So that should be fine. Get rid of that. Right, then we have the renderers. There's particle renderer. Or we can just call this R. And now we can do alloc.new mesh particle renderer. And it's going to use this allocate handle, so allocating it that's going to show up there in the particle allocations. Client, so that would be client. This is render scene, that's going to be renderer get primary scene, which is where primary scene, which is where all of the Merlin particles currently go. Mesh resource path, material resource path, and sort particles. That's it, and then we return R, right? And here we do R. It's actually called renderer dinit, and then like alloc.delete renderer. Right, so this is arguably even worse than what we currently have, because now we're throwing that thing on the heap instead of just allocating it as part of the node state. But this is going to let us now go into the mesh particle renderer node, and instead of having this thing here, just going to make that a pointer instead. And here we'll want to include a few more things. Merlin effect description and Merlin renderer cache. So we don't do the initialization here anymore. And we don't need to get those anymore either. Still need to get those. And the state renderer is now UD effect description, get renderer cache, get mesh renderer. And we give it the mesh resource path, material resource path, and source particles. Right, and then we can register the renderer. We're going to register it with the instance. So this is the renderer that, you know, we should be using for this node, etc. And then when we destroy the state, we do indeed destroy the state, but we also return the renderer to the thing. Oh, we don't have the user data here. That's annoying, quite frankly. But what we can do is we can keep a pointer to the description around. So effect description desk, like that. State is there, so we just do state desk is ud effect description. And then we can use that instead if we want to. And we don't need to unregister anything like this. We don't need to unregister a renderer here. Renderer. It has some renderers in some sort of list. It's a vector, yes. But we don't need to unregister them, because when this node dies, then the effect also dies. This node dies as part of the effect dying. So there's really nothing to unregister there. It's gonna be fine. So description, get renderer cache, and here we just release the mesh renderer. So s renderer. Yeah. Yeah. That's going to be fine. Now this should actually work. Let's see if we actually get some particles in the game. Yes. And we should still have the ridiculous... I'm underground now. We still have the ridiculous cogs there, I think. Yay. Cog smoke. Alright. So now we are using our new cache, but the cache is not doing any actual caching. It's not doing any actual caching, it's just creating things on the heap, which is sort of even worse than we had previously. But now we can start doing caching. So here's the renderer cache. What should we now do about this? How should we actually cache these guys? Or in particular, how should we identify one of them as like a new thing? One thing we can do is something like this, and then just take these guys and move them there as well, or not move, but copy. Like that. And then we'll quite simply have a list of these. But we want the pointers to be stable. Right, that's very important. So what do we do about this? What do we do about this stuff? We could even do it like that. We'll create it as part of this, and then we'll do in use. Does that make sense? What is it? What does this thing have? It has 4 pointers. It has an immediate mesh batch, which oh, hey Tutu. Oh, I didn't. Oh, did I forget? I'm sorry. Let's make that happen. Let's make that a thing. Let's make that a thing. Yeah, I'm not sure if this qualifies as a SIG stream, since we're doing C++ today, but yeah. I kind of lost my train of thought, but yes, we have 4 pointers there, and we have the batch, which has a vector and some other crap. We have some more vectors and a float. So if we want to keep the pointers stable, either we have to allocate this renderer like actually on the heap, which I guess wouldn't be the end of the world. We're not going to be doing it all the time anyway. Just going to be allocating every now and then when we run out of things. We can keep this other stuff there. I think that's what I'll do right now, and then I'll change it later if I need to. So basically we'll have a vector of cached mesh renderers, and then that thing will still be a pointer. Right. Yeah, let's start with that. That's the MVP version of this. So basically we do this, but we only do that if we can't find another one of these guys. So we'll do like cached mesh render reference cached mesh renderers, you know, and then if cached, so if not in use, and mesh resource path equals cached mesh resource path, and material resource path equals cached material resource path, and sort particles equals sort particles. Then what we do is we set cached to in used to true, and we return the cached renderer. All right. And here what we do is quite simply check if the renderer is the given renderer. And then we can maybe assert that this thing is actually in use, right? Just that we don't have some weird case where we kind of find it there, we do a double release or something. Then we set it to not be in use, and then we return. That should be good. That should be good. And then in here we can just basically release the cached renderer. Oh, not that. Renderer dinit. Come on. Dinit. And then we delete it. And then we clear this whole thing. Right. And then we need to do one more thing here. We'll actually make a new cached mesh renderer. Cached. Something like that. And then do cached renderer is that. I can actually probably initialize it directly with this. Can I not? I think I can. There's resource path, material resource path, source particles, and it is in use. Right. And then we can just do cached.renderer init, and also push cached. Would that work? I think it would. And so now we can actually we can print here, created new mesh renderer. Let's put some stars before and after this guy to actually. Oh, sorry about that. Hitting my microphone here, so that we can clearly see when it has to create a new one. So you should probably start by creating a few new ones. Yeah, created 4 new ones. Most likely because it has 4 wheels. And I can see that it hasn't created a new one for a while. And those cogs are a little distracting maybe. But yeah, alright. So if we play this long enough, we should not see any more of those eventually, sort of. Driving some very bumpy terrain here. Occasionally it still has to create a new one. But sooner or later it's gonna have enough of them to just satisfy this one car for a bit. That looks somewhat promising. So we're still not, of course, doing anything with billboard renderers, but the mesh ones should be pretty well handled with this. I still want to put in that other category to help me track the memory use of the node graphs. That's gonna be really interesting to see how much memory they use. Like I didn't used to have a zig allocator previously. That zig allocator, so basically this zig category here was added maybe like 3 weeks ago or something. And it just behaves very, very sort of exactly how I expect. Oh, gets a little choppy there. Do you mean the stream or the game or what? I think the game is actually running quite well now, just on my local screen. So did you maybe mean the stream? Not YouTube, but the game. Alright. Draw up the new cliffside. I mean, it is possible. I know I have some weird frame pacing issue occasionally, which might explain some of that. It's just that I haven't really seen any choppiness. Or I didn't see any choppiness when I drove up this cliffside a minute ago, but maybe that was like a frame or two drop there just now. Hello, Red Wither ITA. Yeah, there's some funkiness going on with the frame pacing occasionally that I will need to look at some point. Also, I want to not have this cog thing here. Just undo all of that and just save it. We should nicely hot update. Yes, it does, and we get back our normal spheres. What's the problem with the pathfinding or movement? Not sure what you mean. Do you see a problem with the pathfinding? Or is this like in relation to something that I might have said in one of the AI videos? I'm sure there are lots of issues with the AI still. If that is what you mean, but I don't see anything particularly wrong with this current case. Right. So, is this now sort of the MVP implementation for one of these guys? I think it might be. let's do like, let's move this here. And then we can do count. Size. And then we can do the billboards. Right, so billboard particle renderer node. This one is probably doing the same thing. It has the billboard renderer right there, yeah. And this has just the material resource path and whether or not to sort the particles. So it's a little easier. Let's just put it in. Billboard. Yeah, and you could, if you wanted to, you could do like a nicer API that would handle all kinds of renderers or whatever. But I kind of like to keep this super simple and separated for each type, in case you want to handle them separately. And I mean, this is sort of like an implementation detail after all. Unless you're actually making new renderers or node types for Merlin, you shouldn't really have to deal with any of this stuff. Oh. Let's just actually shorten that to BB. BB. BB, 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 BB. Well, that will still be a billboard. Oh, actually not that one. That's still a mesh. Could also mean bounding box. It could, but I typically write AABB if it's an access line bounding box, or OBB if it's an oriented bounding box. Yeah, there's nothing wrong in writing things out, as you say. There is, however, things wrong in just repeating yourself. Mesh billboard. What am I doing? What am I doing? It's supposed to be billboard particle renderer, and then just boop. Something like that, and then we'll do BB renderers and creating new BB renderer and BB renderer. Like if I make a change here somewhere, oh, that's supposed to be BB renderer as well. What? There we go. That's a problem. Yeah, if I make a change here somewhere and I kind of don't realize that, oh, there's actually two of these guys. It's kind of a bad example because it should be reasonably obvious if you just have a glance at this. That okay, kind of doing the same thing. But if I somehow change how this caching works, I need to remember to go through all of this. But like I said, this is an implementation detail. It shouldn't really have to make that many changes to this thing over time. Okay, so now we should get counts printed out for our different renderers. The annoying thing is that I have this SDF renderer here, which is it's kind of heavy, which is why I don't use it. But oh, I bet I forgot to. Oh no, I did actually. I just don't use that yet. That's why. Yeah. Mesh renderer. No, mesh particle renderer node. I guess we'll have to probably do the same thing here. We'll just add the description there. Do the same thing there again. It's probably kind of copy pasted from the other thing anyway. So basically we'll do like get BB renderer like that. State. We need the description and the renderer cache here, so that we can actually do that thing. Here we go. Right, we don't actually want those guys. Yeah, in some like somewhat recent YouTube comment, I wrote that I prefer writing some really basic code these days that doesn't try to be clever. And this is a good example of that. It's just super basic, almost like laughingly basic stuff. Right, so here we have BB renderer account 12, and then we go back to 1, so that would mean that this is actually another event type, another event description. We get a lot of BB renderers if we like stop and start and do these kinds of things, because that is typically when you get that effect. And that makes perfect sense. Alright, I think we'll probably reach the number of renderers that this car requires when driving around this place. Occasionally it might still create one or two more. Oh, we got a few more. But yeah, I was gonna say previously that this guy is kind of annoying. I should probably remove it. Sprinter is not actually smart enough currently to realize that this thing is not connected to anything. And so it's actually always created, even though I don't use it for anything. So I should probably remove it. Will there be NPCs, either humanoid or vehicles? There are vehicle NPCs. We're just looking at one. So you see that big vehicle that's following the small one there. That's the mother vehicle. And the campaign is kind of centered around that one, solving puzzles using the mother vehicle. What if the game had outlines? Well, if the game had outlines, then it would not be this game. That's my answer. Yeah, sorry, that might be a little arrogant, but yeah, I don't want outlines. I already have edge highlights. I think outlines might be a bit too much. But yes, the game has NPC vehicles. You can order your mother vehicle to, like, come here, for example. Now you can see that it's actually driving to you. And you can also switch to that vehicle just by driving up to it, as long as it's staying put. Hello, stay put. You can switch to that one. Now we can drive that vehicle, and now we can order the scout around instead. Hello, scout, come here. You can see the scout is coming to you. So yes, there are definitely NPCs. You have sort of like a gang of people with you on the journey. So now there's Diego, as you can see down there, is the one, is the character who's driving that scout vehicle there. But you can sort of switch back and forth, and the game tries to place characters in vehicles sort of reasonably. But yeah, yeah. Regarding the outline, still, if you look closely at this vehicle, like all the edges are sort of highlighted. Like you have these sort of lighter, or you can see them really well here on the wheels. All the edges have these highlights going on here, and you can even see it here on the cliffs and things like that. And that is sort of the art style. This doesn't have it because this is still white box stuff. Both this vehicle and this part of the level, but here this part that is somewhat finished, such as this shed here, have these outlines everywhere. And so that's the sort of thing I'm going for. Yeah, big trucks are awesome. They're still sort of anticlimactic, this this particular big truck because there are no sounds or particle effects or smoke or anything. And so I need to do a pass on this soon, but I've been I've been saying that for a while. I know it's kind of still hasn't really materialized. Where did my scout go? There it is. Right. Yeah, I wonder if we could somehow eliminate this thing. See the Trello task about SDFs before enabling this. Yeah. I had some. I kept this here because I have these paths here ready to go if I want to re-enable that one. Does the thing actually work? I'm not sure. We can have a go. See what happens. Yeah, it doesn't need to work. And it also uses the sphere mesh. And they get sort of like they kind of merge together. Yeah, this is actually kind of heavy. Actually kind of heavy. Blood dust bin shader. I think that's the one that I have. It doesn't actually look like they're merging almost at all with the current settings, but yeah. Anyway, wonder if we could eliminate this from SDF. Particle renderer node. So basically, nodes further down the stream can figure out, hey, do I have anything connected to one of my pins? I don't think this guy can actually determine if it has anything detected to its output pin. But if it could just not create the renderer. Yeah. I think I'm not gonna spend any time on that right now. Just gonna make the cache work with those SDF render as 2. And then I'll have a think about that. But basically, SDF particle renderer. So it has an SDF placement scheme. I guess that thing might eventually have some other things in it. Let's assume it will. I'll just include this. It's just a type header for Merlin, so it should be fine. Cached SDF render. We have mesh and we have shader, not material. This uses just a raw shader. You can do essentially anything you want in. Yeah, that looks all right. So that's shader and that's mesh placement scheme. And then we still have mesh scale multiplier. And we have some mesh crap to replace with SDF here. SDF is so nice to write because like SDF buttons on a keyboard are just right next to each other, at least on my QWERTY keyboard here. It's so satisfying to type it out. Just 3 keys right after each other. Small choice in life. Like that, and then we have right, so we have shader, mesh placement, and mesh. Oh, what? Sort of like that. Right, so mesh renderer, billboard renderer, and SDF renderer. So is that it for our cache for now? I have a feeling it might be. And then we just need to hook it in. the node. So we want those two includes, that turns into a pointer. We add the description pointer there, and we set it. This is where we release the thing. So release SDF. That address of goes away. State renderer equals get SDF renderer. Then we take those away, and that's it. All right. I think that's probably it. Yeah, this setting up is kind of weird now because we're getting a renderer pointer from somewhere, from the cache, but well, from somewhere, and then we're registering it here, and we're getting back an ID, Polygon renderer ID. That is essentially sort of the actual thing that we then keep track of. And the reason we do it that way is that this pin here conceptually sort of outputs a renderer, but we can't like copy renderers around, or we can, but that would be stupid. I could just output a pointer here, but that could lead to all kinds of problems. So what I do instead is that I map it to like an ID, and then this pin actually outputs the ID. So when we get pin value here, what we actually write to the pin is like the renderer ID. I think this register renderer, this is just like this per instance, and it's just a running number. So there's quite a bit of indirection there to actually get those renderers hooked up properly. Oh, hey! What's going on? Release SDF renderer. We want this to be in use. It's not in use. Why is that thing not in use? That's strange. Let's put a optimize off there. You made me look at pictures of the Liebherr LTM 1500. That looks like that sounds like a very manly vehicle. It's not in use, even though we said it to be in use. What? What? All right, I'm gonna have to look at this thing now. Right, so it's sort of like a crane vehicle, this kind of thing. And one could be yours for only 1.7 million euros. All the buttons. Oh. Suddenly full screen. Yeah, that's a pretty manly vehicle. For sure. They got like one of the... What do they call, like... Is it like mining dumper? Dumper truck. Like one of these would be pretty cool to have. You know, you could just like drive over every other person. I want more images. Yeah. Right. Let's see what's up with my weird caching here. So it is in use. The confusing part here is that it claims to not be in use later on. What do we have here? We have 1, and it is in use, right? Yeah. Where? So either we're doing a double release or somehow botching the creation there. I don't get a call stack. Why don't I get a call stack? It's because I have this here. Let's see. State render. I want the format string. What the hell? Yeah, that thing is not a string. I don't know why this can't show it to me currently. But then we release it immediately, and we set the thing to be in use. True, yes. There's something wrong here. Clearly, because this thing still has only one of those. Oh. That's probably what this warning was about, right? The use of comma operator in a tested operation causes the left argument to be ignored when it has no side effects. What? What? So you can do like if true, false, true, 1. Alright, can I do that? Yeah. Alright. Which one of you knew this was like an actual thing in in C++? I don't think I've ever written this kind of thing, and I happened to do it by accident. That's weird. Alright, today I learned that this is a thing in C++. That should fix the problem. Yeah. That's better. Alright, so we're getting the new SDF renderers. Yes, yes. Kind of unnecessarily, yes. But still. Memory stats. Like, in theory, we should now have less stuff going on. And you can see actually that the GFX API memory use is now much more sort of subtle. Whenever we get one of those created new something or other there, it's typically paired with a few new allocations on the graphics API side. But when you don't get those, typically don't get any GFX API allocations, which is nice. Hey Matt, every day is a what the fuck day with C++. Yes, kind of is. The solution is to use something else. Actually, you can still be what the fuck with C++ even though you're using something else. Alright. Good. That's better. Now, if I actually do it... Oh. Hey. Hey. Aha. Yeah. So we have unreleased a whole bunch of things here. Yes, I think I know why. If we go to the cache and we actually get rid of the things, we should get rid of those issues. Right. Just making sure we are actually releasing everything now. And then I can actually get rid of those SDF renderers just by not having that one node in there. Alright, and now if I shut it down, then everything is cleared. That's nice. Alright, I'm just gonna get rid of that, save that, and export it. Now I hopefully shouldn't get any SDF renderers at all. I do need to give Sig a proper go, but I've been using Go a bit more. Pretty confused by your uses of Go there. Zig a proper Go. But yes, yeah, use whatever is the right tool. Absolutely. If Go is the correct tool, then use Go. If JavaScript is the correct tool, then use that. It's all good. And I mean, I'm sort of shitting on C++ here, but most of this code base is still C++, so who am I to talk? Yeah, that seems to work pretty much how I intended. Not that one, I keep opening that one all the time. Right, and we're actually now down from 6 point something to 4 point something on the GFX API. That's almost 5. It was almost 7 earlier. That's not a big drop, but like, yeah, just as a percentage, it's a pretty big drop. So I think basically what I should do next is try to get that that new memory allocation category set up there, and then we can start moving things from those node graphs over to that one. Yeah, I actually did a little bit of hardware updates to this machine last night. Because this machine was just seriously dying on me. It's got a new hard drive and some more RAM. And now it's behaving much nicer. I think I was actually starting to like swap memory earlier. And the GPU is still a little crappy. It's not like super crap, but it's still a little crappy. And I think a little crappy is just the right amount of crappy for doing game dev. You can't just do anything. You have to be a little more careful than doing anything. Right, so the STL usage is just it's doing so many allocations all the time. That would be actually pretty nice to get under some kind of control as well. It is calming down though if I just stand still, so it's probably something with the gameplay code that does that. I think like even if I move the camera, this doesn't make it change all that much. I can just fly around and look at different things. There's a little bit of change in the allocation there. But not a whole lot. But then when you start to drive around, there's just like a whole bunch of things going on. I wonder what is actually like happening here, because like obviously most of the gameplay code is Zig. You can see that we're not making any allocations with Zig currently. the way that we can get an allocation going is by opening this radio menu or closing it. You can go like from 2433 to 2434 and just back. What are your target platforms for the game? Well, Windows at least. Windows is the main platform. Not really promising anything other than Windows. This engine runs okay-ish on the Mac as well. And I think, like, thanks to the web GPU, if I did a little bit of work on the web GPU backend, I could probably get it to run on Linux as well. So that might be like a somewhat reasonable thing to port to, but I don't think it makes much business sense to do that. It's just more like an interesting technical thing to port this to Linux. But it might be cool to have it running natively on the Steam Deck, for example. I did eventually get a Steam Deck. I haven't really played this on that. I guess it might just run as a Windows build there as well. It would be cool to have it running natively. Oh yeah, Windows for now. Windows for now. 1490s in dev machines do seem to be causing people to forget how expensive some effects are. Yes. Yes. Indeed. And it's not just that. It's also that only using, for example, NVIDIA cards, or also only not also, but only using NVIDIA cards. And not testing on AMD at all, or these days I guess Intel, but I'm kind of guilty of that as well. So, but yeah, that's why I have an AMD card in this machine, not because I particularly like AMD cards, but just because I feel like I have to like actively play this game on an AMD card, and then like if it runs well on this, then it typically runs well on my other machine, which is an NVIDIA machine. And yeah, it typically runs better on that, but it might just be because I've spent more time with this engine on that machine, so I've done more profiling and developing on NVIDIA stuff. But yeah, just using like a 4090 for all your development, that's just completely crazy, unless you're targeting people with 4090s and no one else. It makes no sense to me. Cool, so this works. Let's get rid of these outputs here. To be honest, I think that's another good thing about the Steam Deck. It works as an OK min-spec target plus AMD GPU. Yeah, kind of. The interesting thing is that, like in my experience, I do work in the AAA game industry, if you want to call it that. And for a number of years now, the game consoles have used pretty much exclusively AMD chips. I think the only game console, only sort of big game console currently is the Switch, which uses an NVIDIA chip. But all the other machines are AMD GPU powered. But still, everyone just uses NVIDIA cards to make games. which is kind of crazy when you think about it, because like game consoles are like most companies' kind of main platforms. Still, everyone uses NVIDIA cards in their workstations. And I mean, I'm not saying that you shouldn't do that, but you shouldn't just do that. But yeah, Steam Deck is really nice hardware-wise. And to be honest, if we're being completely honest here, the new Apple chips are actually really good. If only Apple wasn't so closed on the platform these days. But the hardware is really good. It's surprisingly good, even for like gaming and stuff like that. And Metal is a pretty nice API to use. All right. Yeah, I'm gonna take just a quick toilet break, I think, and then we'll get cracking on the memory category there. So let's see if I get my quick break PNG up here. And yeah, I know this is like super high-tech streaming with all the overlay things and everything. Alrighty then. So let's have a look. Here I'm using alloc in this new cache that we created, and alloc is using allocated particles. You can get rid of that optimize off there. We don't need that. So, just a quick run through of whatever got changed. So the effect description, inits and dinits the cache. That's basically it. Yeah. And it has a cache. Right. Yeah, that looks good. You can submit that stuff. And then we need the CMake stuff as well, yes. Righty then. So, then we have the actual, like this stuff here. We're still in the SDF particle renderer node here. Now this node is much smaller because we just have the pointer to the renderer. We don't have the renderer there itself anymore. But we're still doing this just like new, like this. And that means that will just show up in the generic allocation pool, because we're not really telling it which allocator we want to use. That's not really a problem. It's not like anything to lose sleep over. However, it would be nice if we have lots of these states and they get created and destroyed, that they would go into their own pool, so that at least you can see how many you have and their relative sizes. Because now it's just like one big blob, and you have no idea what is actually what. So, if we look for that part, we should see roughly how many of these states there are. So we have quite a few. We have 41 of them. We have Merlin nodes creating state. That's the particle stuff. Then we have Nemo nodes. That's the mission scripting. Sprinter is like the base thing that all of these different systems use. So you can see these are actually really simple things. We have things like a for loop node here. And these also create some state, current index. And then we have timbre, that's the audio system. And all of these guys now allocate a whole bunch of things on the heap. So, something that would be kind of nice is if these states would actually be allocated sort of like with a linear allocator. Right. I think I have a linear allocator, don't I? Basis linear allocator. Is this used anywhere? Detour linear allocator. Okay, that doesn't actually use it. The render command buffer does use a linear allocator, yes. Because the render command buffer is just like essentially filled with commands like this, allocate command, and then you reset it, and it just resets the allocator, I guess. Yes, clear. So it would be kind of nice if a node graph had like a linear allocator that all the nodes could just be allocated from, right? It's just like a super simple little allocator thingy. But this guy actually works with a pool size, so you need to give it a pool size. And then it actually allocates. Bootstrap allocator, what? Wow. Why does it use the bootstrap allocator? That thing has almost no memory at all. What? Bootstrap allocator has 8K of memory. What? So I'm hoping that this guy actually uses some other. Hoping and thinking. Yeah, it's using the renderer. That makes sense. Okay. Thing with this though is that we don't really get any sort of thing passed to us here. Well, we could have, of course, we could have like an effect instance, for example. Effect instance here, in this particular case, is this guy could have actually like an allocator that it passes to these guys. What about the sprinter things then? Go to the for loop node. Like this guy doesn't necessarily have any kind of user data at all. Search for that again. Yeah, so one thing would be to do something like this, where you have like what's it called? Is it basis allocator handle? No. It's this is mem allocator handle. Yeah, handle like this. I usually call it alloc, and then this is this is whatever we want it to be. So it could be, you know, set it to editor there, but this could be something like node graph. And then you could do this instead. You could do new, and then whatever the state is. Actually, that's not how you do it. It's that is how you do it. And that would put it in its own category, but it wouldn't make necessarily the memory use any more efficient that way. The linear allocator would be cool because it would be very fast to create that, and you wouldn't have to delete those things. Yeah, I don't know. There's something called nodegraph.cpp. And this thing actually calls the create state here, yeah. So this node graph could essentially have a linear allocator. But the problem is that we don't really know how much space the node graph will need. So we would have to make it large enough, or then we would have to improve the linear allocator so that it can expand its space if needed. I mean, that wouldn't be a bad idea necessarily. We could have a pool size and then like a, well, it would essentially be like a pool increment size, right? Linear allocators are not threaded since they are cleared at the end of the frame. That's a pretty bold claim there. I'm not sure that's actually true. Yeah, I think we essentially only have one place currently where we actually use a linear allocator, and that is this render command buffer. Snap Mesh Business is using another kind of linear allocator. It's not this basis. It's this kind of thing. DT tile cache alloc. Cap. Anyway, it wouldn't necessarily be a bad idea to make it so that this linear allocator could expand its size. And the way I would do that is probably have a number of buffers inside of it. I wouldn't try to relocate or expand, like realloc or anything like that, because reallocating can be kind of hairy on some platforms. Or basically, well, you have to kind of do it yourself, which means that I would probably just have like start with a single buffer of some X size, and then I would read from that. And if that got full, then I would just do another one. Like I have some temp buffer functionality here for the render command buffer. There's a comment that the editor sometimes requires truly enormous buffers, and that's why I initialize actually 64 megabytes of memory for the render in all the other builds except the final build. So that's basically what this editor included does here. Yeah, then that size is passed to the allocator renderer. So how much does the renderer actually allocate? I don't think it allocates that much, to be honest. Let's see here. Renderer has 82, so it's basically that one buffer plus a little more. I think it grows a little bit, yeah. 122. But still, like over half of that is just that one buffer, just the render command buffer. So it's pretty large, and of course there's nothing preventing it from just going over that 64 megs, in which case you just get a crash or you get an error and then a shutdown basically. So it could be kind of nice to have it resizable, and if we did that, then we could just give one of those allocators to the node graph. The node graph would just give an allocator to the create state function. That could be kind of nice. They could completely just get rid of the destroy state, because there would really be nothing to destroy anymore. But you might still want to have it, because you might want to de-initialize the state there. Yes. Yes. Okay, so how do we do that then? I mean, this is just crazy to me. I don't know why this is the case. Is anything used now? If I just comment that out, just get rid of that completely. Who would want to use the bootstrap allocator for anything? Because it's like 8K of memory, and most of that is probably used up by. Like the bootstrap allocator is used to allocate allocators. That's why it's called bootstrap allocator. And it's not supposed to be used for anything else. But yeah, nothing seems to be using it. Thankfully. So I'll just get rid of all of this crap. Yeah, and like we don't have reallocating for the linear allocator here. kind of thinking that's probably for the best. Except the linear allocator will kind of do a realloc if it can't find enough space in its already allocated memory. If that makes sense. Okay, pool start. So this guy just basically has a pointer and an allocated size. So what we could do then is just have like struct pool. And we move the pool start there. And we can move these guys there as well. Pool size should still be outside of it. Right. So the pool size you give it like 8 megabytes of pool memory, or 8 megabytes of pool size. We'll create one pool of 8 megabytes. And then when that is full, or it is full enough that it can't find actually a space within it, it will just allocate a new one of 8 megabytes. And if you ask it for more than 8 megabytes, then it will return null. Go like, nope. No, I can't do that. Right? And I think what we might want to have here is sort of like a max pool count, right? So you give it an allocator type. That is the underlying allocator that this guy will use. It's used to allocate a pool. And basically you give it a number, the maximum number of those, and it will just allocate an array of those. Yeah. Yep. That's how we'll do it. So, pools. And I typically use M on, not underscore, but just M. And then whatever for a member. But for small structs like this, I don't do it. So I just took those away there, as you maybe saw. So we'll have pool size, and then we'll have another size t, which is max pool count. Right. Right. And then we'll put that there as well. And I think I'll want to have we'll see. Sort of thinking out loud here, but no actual fully formed thoughts. Let's move this to the other side. So, get rid of those. And what we'll actually do here is, the first thing we'll do is we'll allocate the array of pools. So that will be malloc handle. Oh, we actually, yeah, that is there. That's there. Never mind. So new array of pools. And that would be max pool count. So pools, we can initialize that to null, and we can set pool size. Let's change the order of these to have it in the same order as in the header. Pool size and then max pool count is max pool count. Right. Actually set all of this to 0 here. 0, 0. And then we'll do for the first pool, we'll allocate pool size. Here what we can do is just, if pools I have a pool start, then actually just free that. And then delete array m pools. And then resetting this guy is clear here. It's actually just resetting all of those. So basically, actually, it's almost exactly this. Clear is that, like so. And here we want to count, initialize that to 0. Well, we'll just add that there. And here we're doing the size instead. Allocated size. So maybe that can be called size instead. Is thread safe? I mean, this is not really true. A linear allocator can be thread safe, but it depends on the underlying allocator. So, yeah. So how this should actually work is something like this. We'll take that away. Get pool size is there. We'll put this right after that one. And then we'll do a return mem get allocator for alloc handle is thread safe. To get the type out of it, yeah, like so. That looks better. Yeah, this aligned allocation should be fine because it actually calls into this allocate. So that's fine. We just need to hook this up. And basically now what we need is like if size is larger than pool size, then we're out of, it's kind of out of memory, but the actual error is like the requested size doesn't fit in a pool. Like we can always allocate a new pool, but if the pool size isn't big enough, then we're kind of a pickle. Right. Times is last used. Yeah, this is the thing that actually turns those things yellow in the whatchamacallit. Memory stats window there. Let's get this bootstrap stuff away. I don't know why I do that. That's kind of annoying. Or it's completely unnecessary. Let's not do that. And now we need to find the pool to actually use. So basically, we can do this void void p equals null pointer here. And if pool start, then we'll see if sorry, actually, yeah, if pools I dot allocated size, so actually sort of free size. Free size is of course pool size minus allocated size. Is large enough, then we can quite simply do pool start plus allocated size. And then we do pools I count. We just increase that, and we do pools I dot allocated size plus equals size. Right. Now we essentially have the thing. Maybe we should actually just break here. We have set p. We might want to go to this meme trace stuff, so we just return p, right? That seems reasonable. If the pool has enough free memory, use it. Then if if it doesn't have enough memory, but there is a pool sort of if it doesn't have enough memory, but it has a pool start, that means that it was quite simply too small. Pool is too small for the request, right? And it is kind of interesting to sort of think about this from the perspective of like a true linear allocator would just like return addresses that are growing. But in a sense, this is not a true linear allocator because we are allocating different pools. So later on, if you request memory, it might actually return a smaller address just from a later pool. That is completely possible. Yeah, so that's a little that's a subtle quirk about this implementation, but it's probably fine. What I'm thinking here though is that do we want to actually sort of mark the start pool to start looking for and just always jump to the next one? Or if we're allocating like a pool size is 10 megabytes and we're allocating first we're allocating 6 megabytes, so that leaves 4 left in the first pool. Then we allocate like 7 megabytes next time around. That would jump to the next pool. It would still leave those 4 megabytes free in the first one. Then if you allocate 1 megabyte after that, would it go to the first pool or the second one? I guess it probably should go to the first pool again and look through the whole thing again to see if it can find space there. Which it does here if we just always loop through the entire pool count. Yeah, I think that's probably alright. So pool is too small for the quest. Not sure if we want to do something there yet, but we might want to. If we come here, we don't have a pool start. That means that we actually need now to allocate a new pool here, like that, and then we can quite simply set p to m pools I dot pool start and we can set this to 1 and we can set that to size and then we can break. Maybe that's nicer, have it in that order. Here, if we still don't have a P, if we run through all of the pools, still don't have a P, then we are out of memory. That is out of memory. And yeah, here we might now want to actually just revert that. Allocate follow the formatting of that comment. So if the pool is not yet allocated, do that now. Yeah, I think that should work. Right, we actually have an error here. So we have the buffer size, right? Maybe we should use the same vocabulary that we're using here for this as well. Pool size and max pool count. Like that, and that will then just get rid of that completely and just think about how we want this to work. So we'll do size T, pool size, and I'm not saying that this is now necessarily the correct way to do it, but just let's see what happens. Let's allocate. Let's have a pool size of 8. And and then we need a number of them. If my math is correct, then 8 times 8 is 64. Indeed. So so we'll do 8 megabytes times 8. Max pool count. Actually, this should be. And then we do temp buffer mem. New render command buffer. And that would be pool size and max pool count. And why don't I actually use that one to allocate the actual buffer itself? That would be much nicer. Something like this. Something like this. So alloc. Here we can just pass alloc. Dot is it get allocated type. And here we can do temp buffer is alloc new, and then pass this stuff to it like that. And here we can do no, we can do alloc dot delete. Yeah, it's delete with a big D. So now we should start with a much smaller buffer and then grow from there as needed. Pool size 8 might be a little small. Might be that we just need more, but we'll see. The last thing I want to do is actually in the linear allocator. I just want to print something where when we actually allocate one more of these so we can see it. Linear allocator grew. All right. So what's the memory use now then? Memory stats. Renderer is 26 megs. So actually significantly smaller than previously. We should probably see it growing almost immediately. Yeah, it's up to 66 now. Do we have any of those? Those 3 stars here. We interestingly don't. At least I can't find it. Oh, render command buffer auto memory. So what did we do wrong here? What did we do wrong here? Okay. So we're probably just allocating like an enormous amount of stuff, right? What is the size? Size of T. Right. Let's put a breakpoint there. And we need to do something like that. So we need to make the pool size larger for the render command buffer. No, that's fine. It used to be like 64 for editor enabled builds, so it's quite reasonable that 8 won't do it. But let's not bump it up to like back to 64 without seeing what it actually needs. Okay. Why don't we actually get... Strange, why don't we actually... Did we go there? I guess. Okay, one more try. Don't hit anything now, I'm gonna have to properly investigate this. Also, I wonder what is happening there that it actually... Can I just fly here and have it trigger sooner? Does it look like it? Right, so we're going there. Size is 32. Okay, okay. So pools, let's add that to the watch. And we'll just add it here. Allocated size. Okay. What? It has not tried to actually do that. Okay. Let's see if we can. Can I just move that back there? Seems like I can, because that's 8. Right, so then it should go back, and it does. And now we're at 1, right? Yes. All right. So what is it like initially then? Interesting. Okay, so what we'll do instead is like put a breakpoint there. So if it doesn't get the stuff from within the first pool, it needs to go to the second pool. then we want to know about it. Isn't this fun? Watching someone debug their memory woes on the internet. Isn't this fun? Are you not entertained? Okay, here we go. So this should be 1 now, right? Oh, this is actually 0. Yeah, it's still 0, of course. And it should skip this. Yes, it does. And it goes back there. Ah, right. Okay. That's the bug, isn't it? That is the bug. So if pool start and if we have a pool start, then we want to check this thing. Otherwise, it's just gonna return a null pointer from there and then be confused. Sort of throw itself into a knot. Vibes are chill though. Yes. Yes. It's been a long week. I don't have the energy for anything but chill. So now we should start seeing those render what was it, linear allocator grew or whatever I wrote there. Yes, linear allocator grew. It's nice, and it just might grow again, but I think we might have to do something drastic, such as turning on like what do we turn on? We turn on like nav mesh drawing. Oh, we can't turn on nav mesh drawing because we're not running on the same excuse me, thread. We can turn on AABBs. This might actually just break it, but let's see. Ah, there we go. Haha, it grew twice. I'm just drawing normals on all the models now. Yeah, and it's pretty slow now because it just has to transpose every freaking vertex in the scene. All of these things. All of those things. Every freaking vertex in the scene now gets transposed individually. Everything. All these things. Whether they're on the screen or not, I should add. So it's actually kind of... I'm kind of happy with my 20 FPS here. It's a reasonable frame rate or something like that. Everything that has a mesh instance, I should perhaps say. You'll notice that the particles don't actually do it. Neither does the terrain, nor the grass, nor the sky. None of those are actually mesh instances. Okay, but that's good. That's really good. And what I think I will do now is I'll just shut this down first of all, and I will actually cut this a little bit of slack, and I will bump up that thing to 16. And so 16 times 8, that would be 128 megs that it can allocate if it really needs to. Did I get that right? I think I did, yes, 128. But it starts with really something quite low. Render 34.3 5. Yeah, this will be good. And now we can add those linear allocators to the node graphs, which is what I really wanted to do. Yep. This looks like it's working. Whoa. So we can take that away. And that's basically everything we need to do, and I'll take that away. I'll leave it there if I need to debug this later on. And that needs to die in a fire. That's horrible. I should probably do things like this more often. Not sure if this is like good streaming content, but it is good for the health of the code base. So let's have a look at what we did. I immediately see that the first line is a bit long. It's tricky to read if we're on a tighter screen estate budget. So allocating the pools, we are setting everything to 0. Like this, in theory, we shouldn't need to even do that. If we don't do that, then it will be allocated on the first actual allocation. Which I don't know if that's like a good thing or a bad thing. Maybe I'll actually remove it from there. There's really no reason to do it unless we like actually use this thing. We don't need to allocate anything. Let me just make sure this actually runs. It does run. Yeah. Right. Let's write a comment here just to remind myself later, or anyone else looking at this. Not a typical linear allocator in the common sense. No, in the sense that it allocates multiple pools of a given size rather than using one large pool. Because of this, the addresses returned by the allocator aren't necessarily located addresses returned by the allocator aren't necessarily how should I put this, like rising consecutively. I don't know how to write this. Aren't necessarily linear in the sense that alligator, in the sense that each address is larger than the previous one. Something like that. Yeah. And then we have the header. Yeah, I think this linear allocator is pretty old. So I haven't looked at it in a while. I'm getting shocked here by my use of the, or my suggested use of the bootstrap allocator. I don't understand why that would be a good idea. Right. Yeah, it makes sense to have a slightly larger buffers there in case something needs to do like a really large individual allocation. I don't think they should need to do that, but still it makes sense to do it like that. Yes. Yep, that works. Just making sure I don't have any crap lying around. I don't. Okay, nice. Okay, now I will make a slight API change to the node graph system. This is the stuff that I actually sort of want to do now. Node graph. So this guy should get a linear allocator. That it can use to pass to the states. Let's put it up here. Memory. No? Is it core, maybe? Memory, yes. Except, probably actually in the linear allocator, basis linear allocator H, yeah. Where's that? That's in memory. But this thing is not actually including the memory. Oh, it's probably because system is including memory. Yeah, it's right there. Okay. Where's this? Is it in core as well? It's in memory allocators. Okay. Cool. So, let's give this guy a basis linear allocator, node state allocator. That's what we will call it. Yeah. I will do something similar that I did here. And that this is not going to be a renderer. This is where we can then, if we actually plug the new category here at some point, we can use that. But for now, let's just use allocator generic. Oh, it actually already has one there. Huh. I'll get rid of that. Yeah, because the initialization order thing is not something I want to have to deal with ever, so let's just do this instead. But yeah, all of these things could be then... all of these things could then be initialized with that same allocation handle. Node state. So it goes like roughly around there. And this is node state allocator pool size. Okay, so we need to come up with some numbers here. Node state pool. What do we make this? Maybe like 8K or something. Node state pool size. And the node state max pool count. That can just be 8 as well. That's alloc. Like that. Comma. No comma. What? All right. What's that? And the virtual allocator should then take care of freeing that. We don't need to do anything to have that happen. And now then, we have this create state function pointer, which we've seen previously. So this guy could basically just take as a separate, as a second parameter or third parameter. actually probably a first parameter now that I think about it. Could take the linear allocator. And I'm gonna pass it as an actual linear allocator here. Not like a memory allocator base class or anything like that, because I want to make it very clear to the user that, oh, this is a linear allocator. I don't need to delete anything that I create with this guy. And now the thing that we looked at previously, which is like create state, and it would be basically like this thing. We want to basically like replace those with create state basis linear allocator pointer, and then this guy. Node state alloc. Let's do that. See what happens. I might just break so many things now. It's not even funny. Can I build Sprinter? Right. I need to actually pass it the thing, right? And I need to pass it the address of it. Like that. Yes. And I guess in some sense this is kind of nice because I don't need to like manually go through and port all the nodes to this. I can actually do like a few at a time. So if you look at the Sprinter nodes, these are the these are the ones that are kind of like considered to be part of the standard library of nodes, essentially. Right? So I don't really need a destroy state anymore. I can just take that away. I don't need to register that at all. What I can do here now then is, let's look at the render command buffer, the header. Right, we allocate like size of the thing we want to do, and then we can placement new with this like this. Yeah. So rather than doing state equals mem new state, we do state equals new, and then we need to do the node state allocate size of state something like that. Yeah, that's an incomplete thing. Yeah. Okay. Probably missing one closing brace there. Yeah, basically like that. Is that cool? Not sure. Should we just have like should have like a templated helper to make that a little easier? Not sure if I should. Now this is kind of a mouthful or a handful if you're writing it. So basically, probably have some handy sprinter header here, sprinter.h. So what I could do here is just have like a templated helper function here. Or maybe here. Oh yeah, I can look at that later. It's not super interesting right now. What is interesting though is if we can actually use this now to allocate our states. So curve node, like this. And it's actually just something like that. Delay node, blah blah blah. Yeah. Let's just see if this works. Right. Allocated size, allocation count 1. Okay, so we actually allocated probably another one of those. Allocated size 5, so 5k, right? So the 8k is actually, it's not like super large actually. Probably gonna run out of memory with those buffer sizes. Yeah, let's put a helper here, which will assert that we got the memory. So we'll do like a template. Maybe I'll put it just there at the bottom. Right, we already have the linear allocator. Yeah, this makes perfect sense to have it here. Template. In fact, I'm gonna go as far as including this memory allocators linear allocator right there. So state type, and should be maybe, yeah, I think we'll do like oh, that needs to be type name state type, of course. Type name state type. We'll do like a variadic template here, and it gives us back a state type pointer. Allocate node state, and it just takes the args. I think, if I remember correctly, this is how you do variadic template arguments. It's kind of a weird syntax. And then we can do, oh, and we need to, right, we need to actually give it the allocator. So basis linear allocator. Let's call that A. Oh, args, like that. Right, and then I'll just copy that from the render command buffer stuff. So A would allocate the size of state type. Then we create it like this. That's the state. We can actually just return the state. So I'm not going to do that because I might want to, yeah. I'm going to leave it as it is for now. State. And then I'm going to return the state. Yeah, this is much handier if I actually want to debug this and see what the state is. Even though it looks kind of unnecessary. Right, like that. And then node graph linear allocator. Oh, what do we call it? We call it state node state allocator out of memory. Something like that. Where was the node graph CPP? It's right there. Node state allocator. Node state allocator. Nah, sure. Linear away there. Allocate node state. Right, so now we don't have to do that. We can instead just do state equals allocate node state state, and we pass it the allocator like so. Isn't that nicer? I think it's nicer. And I think for most of these it's gonna be just a straight replacement of that thing. Where's create state? Create state is right here. Delay node state, okay. So I'll just return that. Delay node state, return it. And again, we don't need that. Yeah, so I'll just do this for the Sprinter ones, the standard library ones, if you will. And we'll see how this works. For loop state, okay. Return like that. It's generally just an int that, so we could essentially just get rid of the state completely and just allocate an int on the heap. Allocating an int on the heap is a little silly, but it's technically just as silly to allocate a struct on the heap which contains just an int. But it is what it is. Right, so there's a vector of 2D curves. Cool. Right. Multi-curve we did. Take that away. Alright, so about halfway there. We can see that almost none of these states actually do anything other than just deleting memory in that destroy state function there, but some of them might do some kind of unregistering, and in that case we need to support running a destroy state step. Right, so here we're just allocating an unsigned integer in the heap, which is a bit silly. At least now we're just placing it in the linear allocator, which is nicer. Alright, where's create state? Create state is right there. right? And here we have a bool. Here we have something that's arguably even sillier to create on the heap. It's like a single bit essentially, but of course it gets allocated as a byte in this case. But yeah, that's kind of stupid in a way. State. Track condition node. Yeah, this has a little bit more meat on its bones. This guy. But yeah, I feel I've been influenced by Zig enough that I feel kind of comfortable now just passing allocators to functions. Just like yeah, that's how you allocate stuff. Just give the allocator to the thing, and then it knows how to do whatever it needs to do. That is something I really like about Zig these days, that are very explicit, and that is probably how I managed to keep the heap allocations on the Zig side. Oh no, what is going on? That needs to be that's a pointer right there, so it needs to be an arrow. Okay. Don't mind me. Yeah, Zig's treatment of allocator is probably how I managed to keep the Zig side so very sort of low on allocations, on heap allocations. Because you're just thinking about that constantly when you're writing Zig. Where does my memory come from? Which is very nice. Very nice indeed. Yeah, compilation takes a while. Right, so I probably have maybe like half an hour left to do this today. Maybe a little more, but not like a whole lot more. Yeah, we're just building the whole engine. Rebuilding the whole engine now. takes a while. Alright, almost done with the core. And then the projects that use the core are considerably smaller. Do have some warnings though, 250 of them. Most of them are just conversion things, and then this unscoped thing, this is like the most ridiculous of warnings. Yeah, actually most of them are actually that one. Yeah. Alright, so now we're building a bunch of the nodes. Get some so loud warnings here. That's pretty expected. That is of course third-party code. I could, at least in theory, fix those warnings, but I kind of decided at some point that I'm not gonna touch that. Alright, and now we have arrived at the game projects. Actually building project slide now, the previous game that is not actually a Zig game, but a C++ game. So I tend to keep that as part of the whole package to make sure that it builds. Because it's useful in many ways to have that project working as well. Even though it's not technically needed for this project. Alright, there we go. And now then. Now let's play. Actually, what I think I want to test here is how much memory we actually need for those node graphs. So I think I will probably have to just make those buffers and those pools a bit smaller. And then see just how large they need to be. And I guess that's something that I probably should make adjustable. So if we go to node graph up here and just make that like, I don't know, let's make it just 1, see what happens. I'm guessing we'll run out of memory pretty quickly. We'll see. Yeah. Node graph node state allocator. Node graph node. What are we actually doing here? There's a Merlin effect. Right. Direction 3D with deviation. Yes. Okay. Yeah, that's what I was thinking. I think I'll actually probably... I'd like to pass them here. The problem is that this state allocator wants them already in the constructor. So that's a bit annoying. So basically what I can do is I can move that allocator to the heap and create it here right before this for loop. I guess that's what I have to do. Can't be helped. Let's not worry about that now. And just move it there. So this would just be a pointer. And I'm just gonna forward declare this guy instead. Like so. Node state allocator. Yeah. So node state allocator won't have all of those all over there. It would just be a null pointer, and then we can do it here instead. So node state allocator, and this we can actually use alloc here to create that as well. So basis linear allocator, and we want to pass all of this stuff to it like that, and then we want to take that address of operator away, and here I want to actually alloc delete node state allocator and annul it. Basically like that. And then we have the node registration, node graph node state, so node graph state allocator, something like that. And now we can move those things here. So let's put in some reasonable default values for this. Like that. Yeah, that looks good. Maybe we'll make it 16K. Just so that we have enough memory for like the average use case. What's going on? Unresolved external symbol. Linker error, that's fun. Isn't like linear allocator is exposed? Yeah, it's basis API. So it's complaining for node graph.obj. Right. Right. What have I done now then? Memory allocator dot update. Yeah. I have a hard time imagining why it would actually care about that. Memory allocators. Update is right there. Like this thing is not marked as like DLL exported. With this basis API specifier. The linear allocator is though. So we should be able to use this and just create these things normally. So what is that? What is the problem here? I don't get what the problem is here. Is it that we somehow can't do it like that? I don't know. Yeah, so now it builds. If I add the delete back, it still builds. But I can't create it on the heap like this. Like what? Why? That's stupid. That's stupid. Let me see if I can figure this out. Mem get allocator. Shall we say alloc dot get allocated type? Okay. Allocate. Yeah, so the OLO that we're trying to use is this one. Just mem colon new, and then you pass something to it. And that calls new with allocated generic. That is how we actually sort of fall back to the generic allocator, and then again we pass on the arguments to that. And then we go to that, and that would be basically like this guy. So if we just take that out, actually, do something like this. We need to prepend that with mem. Inaccessible, oh. Well, that's whatever, we'll just do mem allocator. What is it? Probably it's just basis memory allocator A. And then we should be able to do like A to allocate the storage of that guy. And then we should be able to pass all of those things to it. And it's not T, it's actually that. And that would be like that, right? Oh, we need the new keyword there. Something like that. That is basically like opening up the thing. But it doesn't allow us to do that for some reason. It's weird because it allowed us to like have it as a member here. That's strange. That said, I'm not actually against quite simply exposing that stuff. I think it probably should be exposed. That means a rebuild though, unfortunately. Let me actually undo all of the stuff if I did something weird earlier. But I'm not exactly sure how it allowed us to do all that stuff when it was just a member of this node graph. That's a bit confusing. But hey, we've been confused by C++ several times today, so I guess it's just part of the deal. Alright, OBS is telling me encoding overload and consider turning down video settings or using a faster encoding preset. I'm guessing this compilation is just using up all the juice. Yeah, CPU is just at 100%. Don't worry though if you get any choppiness. There's nothing particularly interesting happening. Until we get this thing built. And unfortunately changing like a memory allocator header just causes everything to be rebuilt. That's like one of the most annoying things with C and C++. It's just the way that includes are handled and how there's really no logic or intelligence in that system of like what needs to be rebuilt. It's just like, no, we've changed this, now everything needs to be rebuilt. Yeah, memory use. So I bumped it from 16 to 32 gigs last night. It's now at 13, so would have been pretty full, but now we have lots of memory to spare. So that's nice. Alright, we're almost done with the core again. I kind of know certain files. There we go. Done with the core. Now we have like, I don't know, 7 other projects that need to be done. Some of them are actually really small. "90% convinced that many of the people who are raving about Rust just don't want to deal with C and C++ build systems." And that's fair. Yeah, I wouldn't maybe go as far as 90%, but that is definitely a reason to use a more modern language. Whether that's Rust or anything else. Absolutely. Then again, Rust is slow AF to compile. Yeah. Is it still slow though? I haven't really done Rust in a while. Or ever. I've done a little bit of Rust, but nothing to brag about. Is it still as slow as it used to be? Like Zig is attempting to be fast to compile, let's just say. It's not currently very fast to compile, and it's actually gotten slower. But they've been doing some renovations in the compiler there, and as far as I know, they are actively working right now, making it faster to compile. And they want to get to some like almost like sub-second compilation thing, which would be really nice. Okay, so now we can build this again. Whoop-de-doo. Fun. Having worked with C# for quite some time, I would say that it is very nice when things compile lightning fast. If they can get it as fast as C#, then I will be pretty happy. And if they can get the live edit working, then I will be even happier. Right, oh, still not that. Not memory stats. Right, okay. So things seem to be generally working, alright, that's good. What we could do now, maybe as a sort of final thing today, is actually add that node graph memory category there. Actually managed to like reduce the overall memory consumption by a little bit. It's 2.04 gigs now. It used to be a little more. I don't remember exactly what it was, but it was a little more than that. Which is kind of nice, considering that we haven't really done anything to like reduce memory use. Well, we did make it allocate those render command buffers in smaller pieces. So I guess that might be it actually. That is probably what gave us those extra few tens of megs, I guess. Yes, fast comp is one of the great things about Go, and it's one of the core reasons Google created the language. Okay, fair enough. Fair enough. Oh, I'm sorry. I'm hitting my mic again. So, how do we create this category? It's actually kind of simple. It's kind of simple. Actually, what I can do now is I can hack this a little bit. Let's hack this a little bit. So we can go here and we can look at the middleware categories here. We have 3 of them. That's just pretty useful if you want to integrate something. You can see here that I've used it for fmod previously for middleware 1. I don't use fmod in Traction Point, but that's what it was used for. Number 2 was used for like a bullet integration in slide, and number 3 I don't think is used for anything. But what we can do just to quickly sort of test this out is create a new allocator, register it with one of the middleware ones, and then forward all the node creation stuff there. That should be a nice and simple little thing to end today's stream on. So let's do that. So go to Trampoline app, and we can create here a new heap allocator right next to the Zig one, which we just called node graph allocator. And then we go here and what was this? Is it like thread safe? Yes, it's thread safe. That's what it is. So we do basis mem register allocator, and then we give it the middleware number 3, for example. Nothing else was using that. And then we call this like node graph. Like so. And let's hope that is all that needs to be done. So now we have an allocator. It's hooked into this middleware number 3, and it shows up in the list as node graph. And now we can just go into the node graph, and we make this use middleware number 3. That should be everything that's needed. What are you using for 3D audio instead? I am using So Loud. So Loud is this thing. Easy to use, free and portable C and C++ audio engine for games. So this is what actually plays the sound. But of course I have my own system that kind of wraps that, which is called Timbre, and which looks like this. Where you have like a node system, and you can
emergency protocol dictates that all personnel,
you know, can do things like this, and you can then actually you can do things like this, where you have like a number of wave assets, and then you select random branch things, and you get like a different sound all the time, every time you run this, things like this. So that is what is used, of course, not just for 3D audio, but for all audio. Okay, so node graph, 2.69 megs. You can see that immediately when we start messing around with this, you can just notice that count just getting bumped. And then when we stop, it goes back down to 51. Yeah, that's interesting. I wonder if it is those... if it is those cursors, sprinter cursors, actually allocating that insane amount of small allocations. In which case, we kind of know what to do now, right? We just allocate them in in clumps rather than individually. And you can still see the generic one, the generic allocator, just doing all kinds of things, and that is of course because we only moved over the sprinter nodes to use that new allocator. So only the sort of condition tracking, delays, generic like math nodes and that kind of stuff, only those nodes are now actually using the new allocator, the linear one. So all the nodes that actually do interesting things. So for the audio engine, that those would be like the audio nodes. And for the particle systems, those would be like the particle nodes. And for the mission scripting, those would be the mission nodes. Those still aren't using that. It's insane how much tooling you make. Yeah, it is. It's a little insane. I should make the game as well. Stop making tooling. But yeah, I have a lot of tooling in place. That is true. And part of that is that I want to actually potentially make this game kind of moddable for you guys. And if I were to use like Fmod or something like that, then it's always a bit hairy when you want to allow third parties to modify something if you are actually using like an off-the-shelf editor for that. So basically, like if I use Fmod, which is an excellent audio system, by the way, much better than Timbre for sure. But if I were to use that, and I would adhere to their terms of service and all of that, you get to use it for free if you don't make that much money, basically. So it wouldn't really be a problem to ship a game with it. But then if I made it possible to actually add new stuff to the game, would you guys then have to sort of adhere to their terms of service? Like, I don't know, maybe. I don't want you guys to have to think about that. I just rather give you a full solution which has like the audio engine built in. So that is kind of what I'm thinking with this. I'm also running a game with my own engine, and I just wrote a Maya plugin that live links and have that as an editor for everything from materials to 3D models. That's cool. That's cool. Yeah, that is very cool. If I were to start today again, I would probably do the same thing, but I would do it with Blender. I think most of you have probably seen my Blender live link system, which is just like the best thing ever. It's one of the things that I couldn't really imagine living without these days. Just the fact that you can modify things in there and just have it immediately appear in the level and get to try it out. It's just magical. It's the best. The 3D DCC tool as editor meta is strong at the moment. I think it's always been somewhat strong. For better or for worse. I used to work at a company where we used 3D Studio Max as a level editor, and it was just horrible. It was absolutely horrible. But I think with the sort of popularity of Blender these days, that stuff is becoming more common, and since Blender is so infinitely scriptable, it's just like you can do a whole lot with that. So yeah, that's probably what I would do today if I started right now. Just because it takes a lot of time to work on an editor. I still prefer to have my own editor though, so I'm kind of glad I have it. I wouldn't prefer working in Blender, but if I started today with a new engine, I would probably do that just to save on some development time there. Okay, cool. But hey, this works kind of how I was expecting it would. We're up to 3.19 megs now, so you can see that the linear allocator is allocating a bit more as it needs more memory. So that's nice. Maybe we can play around with some other cars here to see. Let's do load test vehicles. We should have this. Yes, so now we have all kinds of cars here. Hello, scout in shed. Come here, and scout on slope, that's that one. Come here as well. If you're on a team, the artist already knows a DCC. That's true. How do you associate scene objects in DCC with components? Just with the plugin in the DCC. Right. I assume that's a question for Marcus, actually. If it's a question for me, then I don't really do that. Yeah, the mother is not that interesting to move around for this because it doesn't do anything with node graphs. But the scout does all kinds of things. What is happening? Don't drive into each other. It's kind of fun to see those guys trying to navigate around. And with more vehicles moving around, you can see that there's a whole lot more going on with the node graphs. Alright, let's see if those guys can actually make it up the hill. I need to end this soon. Not quite yet. Oh, they can't actually do it. No, they can't do it because that blockade is there. Yeah. I should change this so that this blockade doesn't actually block the nav mesh from working. It currently actually does. I can remove this with the script here. Remove oh, that's not what I wanted to do. Yeah, so basically what I did there was I double loaded the mission. Can't have that doing things like that. But yeah, I can remove the smokestack with the script, but it doesn't actually open up the nav mesh. So for that to be the case, we need to bake the nav mesh without the object there and then add it as an obstacle. Just like we did in a previous stream with the gate to the base. That's fine. Yeah, how's the licensing with Maya these days? Is it still as expensive as it used to be? And Maya seems to be kind of nice compared to 3D Studio Max at least. But Maya seems to, or at least used to be kind of expensive back in the day. Okay, cool. Oh. Oh, okay. Yeah, I thought my dust particle effect actually had failed, but it just doesn't appear when we're not driving fast enough. Still somewhat expensive, yeah. I remember at some point there used to be like Maya LT or something, which was like a more affordable version. Not sure if that is available anymore, but all right, guys. I'm coming up in 5 hours here, so I'm gonna end this now. This was a pretty good stream from the memory management point of view. I am, however, going to probably undo this change here and this change here, and also this here where we are registering this node graph allocator, because I probably want to have a think about which one I actually want to use for these kinds of things. Have a great rest of the day. Game's looking great. Thanks. Thank you. Have a great rest of the day, you too, and thanks to everyone who showed up today. Have a great weekend. I might might do a stream during the weekend if I have time, and I think we'll do something more visual. I want to continue my work on the demo level. Probably do the elevator actually next, unless I just bite the bullet and actually do the cliffs. There's a little bit of stuff still to do here in the intro section. Before we can call this section of the level done. So we have these big cliffs here. That stuff is kind of a little bit boring. Not that interesting maybe to look at. Then we have this pipeline here. This pipeline needs to be actually modeled. I'm thinking I'll probably do like I did a pretty nice to use sort of geometry node setup in Blender for actually modeling these pipelines here. So I might do the same thing for these guys, but they need to be properly modeled. This is actually they're like super huge. Here's a person, and he's kind of looking up at this huge pipeline here. So this probably needs to have some like a little bit more detail to convey the scale. And then after that, I think we're basically like done with this area, except for some details out on this plane. But yeah, the elevator needs to be modeled and made working. So that could be a whole thing. And I think I will use this monorail system as a base for it, because it's basically like the same thing. It just like moves up and down instead of along this track. So we might be able to just modify the monorail to act as an elevator, and that should be pretty fun as well to do. But we'll see. We will see. Anyway, have a good one. Hope to see you in the next stream. Take care. Bye.